All right, one final thing we're going to look at with solutions is how those concentrations work in stoichiometry type problems. So remember, stoichiometry problems, we have a balanced chemical equation and we're converting from moles of one part of the equation to moles of something else. So let's look at this problem here. If we calculate the mass of solid sodium chloride that must be added to 1.50 liters of a 0.1 molar silver nitrate solution to precipitate all of the silver ions in the form of silver chloride. So for a stoichiometry problem, these become difficult because you're going to have to convert this to an actual balanced equation first. So we need to look at what our reactants are and what are our products. And you're adding sodium chloride to silver nitrate, so those are the things we're adding together. So we have NaCl plus silver nitrate, and it tells us that we want to precipitate silver chloride, so that's going to be one of our products, and we just have to figure out what the other product is. And this is going to be a double displacement, so this sodium cation is going to want to come over here and now be with the nitrate anion. This silver cation is going to want to come over here and be with the chloride anion, right? So we already have our silver chloride, so now the sodium is going to be with the nitrate, and we have a balanced equation at this point. It turned out to already be balanced. So what we're given is remember our molarity is going to be a conversion factor. So we're going to start with our liters of solution, and then we can go from liters of solution to mole of AgNO3. And in stoichiometry, once we have moles of one thing, we can go to moles of something else. So we can go to moles of sodium chloride. And then where we're headed is we want to know the grams of sodium chloride. So this would be the conversion map that we're going to run through to solve this problem. So look at what we start with. We have 1.5 liters of this solution, and we want to get to moles of silver nitrate. So we know that there are 0.10 moles per every 1 liter because that's the concentration, so 0.100 moles of AgNO3 per every 1 liter of solution. All right, so our liters are going to cancel now that we're at moles of silver nitrate here. Now we want to go to moles of sodium chloride, and remember those are the coefficients in this balanced equation. So although it's not written, there's a 1 here and there's a 1 here, so there's a 1-to-1 relationship between sodium chloride and our silver nitrate. So we get 1 mole of NaCl is needed for every 1 mole of silver nitrate that we have. And now we want to go to grams. So we need to know the relationship between grams of sodium chloride and moles of sodium chloride. Right, and for that we need to get the molar mass of sodium chloride. So 1 sodium, let's just say, weighs about 23.0 grams per mole, and 1 chlorine weighs about 35.5 grams per mole. So sodium chloride weighs about 58.5 grams per mole. All right, so there are 58.5 grams of sodium chloride for every mole. So now we're going to multiply everything on the top, divide everything on the bottom, and we should end up getting that we need 8.78 grams of sodium chloride to precipitate all of the silver cations out of that solution as silver chloride. Let's look at the stoichiometry of an acid-base neutralization solution. So what volume of 0.1 molar hydrochloric acid solution is needed to neutralize 25 milliliters of a 0.35 molar sodium hydroxide solution? So again, the first thing we need is a balanced equation. So if we're adding hydrochloric acid and sodium hydroxide, this is again going to be a double displacement where this hydrogen is going to now want to be with this OH, and this sodium is going to want to be with this chlorine. So we're going to end up with H2O plus NaCl, which again, whenever we have an acid base, the products are going to be water and a salt. So let's kind of look at the roadmap we're headed down. So we're going to take our liters of solution and go to moles of NaOH, and then we're going to go to moles of HCl, and then we're going to go to liters of HCl. Right. So we have our volumes here in milliliters, so we want to convert that 25 milliliters to liters, right? So 1 liter is the same as 1,000 milliliters. So we have 0.025 liters. So we'll pull that out first, right? So we're starting out with 0.025 liters, and I should probably move over. 0.025 liters. And the concentration of this solution, this 25 milliliters, we have 0.350 moles of NaOH per every 1 liter of solution. Right, so that's our conversion factor. Going from liters to moles is our molarity. Now we want to go from moles of sodium hydroxide to moles of hydrochloric acid. So there we're going to look at our balanced equation. There's not a 1 written here, but there's a 1 there and a 1 there. So the relationship between hydrochloric acid and sodium hydroxide is 1 to 1. So we have 1 mole of HCl for every 1 mole of NaOH. Right, so now we have moles of HCl and we want to get to liters, so what we're going to do is use our molarity here again, right? But this time, right, because our concentration of HCl is 0.100 moles per liter, but we want liter on top because that's where we're headed, so we can say that 1 liter of this solution contains 0.100 moles of HCl. All right, so moles of HCl are going to cancel, moles of sodium hydroxide and liters of this solution are going to cancel. So we multiply across on the top, divide by the bottom, and we should end up with 0.0875 liters of solution. So there's an easier way to do an acid-base neutralization in the case where it's a 1-to-1 relationship like this, because in a neutralization the moles of acid equal the moles of base, right? And the moles, remember, are the molarity times the volume, so the molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. So we could have rearranged this and said the molarity of our acid is 0.100. We're looking for the volume of the acid. The molarity of our base is 0.350. And the volume of our base is this 25 milliliters, which is the same as 0.025 liters. So again, this only works if it's a 1-to-1 relationship. Then it just becomes a dilution problem, and it's much easier to solve. Our 0.100 times our volume of acid equals our 0.350 times our 0.025 liters, and our volume of our acid simply equals our 350 molar times our 0.025 liters divided by 0.100 liters, molarity. And we're going to solve for the volume of the acid, and we should get the same answer, that it's 0.0875 liters. So if you're sure that you have a 1-to-1 relationship with your acid and base, you can solve that equation quicker as a dilution. All right, one final solution stoichiometry problem for your enjoyment. How many grams of sodium hydroxide are needed to neutralize 100 milliliters of 10 molar hydrochloric acid? So, we'll have to start with a balanced equation because we're dealing with stoichiometry. So we're adding sodium hydroxide and hydrochloric acid. So we're going to form water and a salt, because we have a acid-base reaction, double displacement. Right, this now is here, the sodium was with the chloride, so we're looking like we have a balanced equation, 1-to-1. Right, and so kind of the roadmap we're going to start with is we're going to go from liters of HCl solution to moles of HCl, then to moles of NaOH, and then to grams of NaOH. Remember, from our mole map, if we have moles of something, we can always get grams of something. So we have 100 milliliters of this solution. We're going to quickly convert that to liters. So we have 0.100 liters. So that's going to be our starting point. This is 0.100 liter solution. And we're going to convert to moles of hydrochloric acid, and we're going to do that with the molarity. So we know that from 10 molar that we have 10 moles of HCl per every 1 liter of that solution. Now we need to go from moles of hydrochloric acid to moles of sodium hydroxide. We use the coefficients from the balanced equation. So we have 1 sodium hydroxide for every 1 hydrochloric acid. So there's 1 mole of NaOH for every 1 mole of HCl. Right, in our last step, we want to go to grams of sodium hydroxide. So we need to know the relationship between grams of sodium hydroxide and moles. So we need to know how much a mole of sodium hydroxide weighs. Right, and we need to find the molar mass of that. So we have sodium, and we look at the periodic table and see that it's 22.99. We have 1 oxygen, which is 16.00. And we have 1 hydrogen in our sodium hydroxide is 1.00. 1.01, we add those together, we get 40.00 grams per mole for sodium hydroxide. So 1 mole of sodium hydroxide weighs 40 grams, so there's 40.00 grams of sodium hydroxide in every mole of sodium hydroxide. We multiply across the top, divide by the bottom, and we should end up with 40 grams of sodium hydroxide is needed to neutralize that hydrochloric acid.